This is Alex Lawrence Barkley here at AutoSens 2017. I'm here with Jack Bennett from Hamamatsu. Tell us about some of the products you've got here.
So Hamamatsu are a big photonics company, so that's technology that uses light. So we're making light detectors, light emitters like lasers and LEDs, and also some of the technology that goes in between like MEMS devices. So today, basically some of our key application areas are LiDAR, which everyone's talking about. So we make the detectors, scanners and light sources, but we're also making devices for laser-based head-up displays, and then lots of optical sensing like gas detection, sun sensors, rain sensors, and things like transceivers for optical communications.
Okay, so let's drill down a little bit as to what you're talking about in detail, because when I think it's an image sensor, it's a camera, right? Or am I wrong?
Yes, you're right, but there's other types of cameras. So actually for basically normal visible cameras, we're not really in that game. We do make image sensors, but for more niche applications. So things like near-infrared enhanced sensors or something for night vision or occupant detection, but not really the cameras. But LiDAR, for example, you can use scanners. So you can build up a picture of the area around the car by scanning or other techniques, not necessarily just with a camera.
And it's a much narrower wavelength, so does that mean you can make it more sensitive as a result, or is that not related?
Yeah, you can. So you can, rather than dispersing the light over a large area, you can use a device, for example, a MEMS mirror, so that collimates the light into a point, and that means you can maintain that power over a longer range, so you've got a better signal or a longer range.
What does MEMS stand for?
It means micro electromechanical systems. So we're optical MEMS, so we call it MOEMS, micro opto electromechanical system.
Bit of a mouthful.
Yes, yeah, it is. But basically, it's very small devices with some mechanical moving parts, some optics, and they're electronic. So MEMS mirrors are a great example of that.
And the sensitivity, why is that important for automotive applications?
So sensitivity is important because if you can have a more sensitive detector, you can have a less powerful light source. So that means less energy consumption, better safety, eye safety, things like that. But it also means obviously longer range. So especially if you disperse light, you're going to lose power over distance as a function of 1 over the distance squared. Well, 1 over distance to the 4 because it's reflected. So if you've got a more sensitive detector, something like a silicon photomultiplier with a gain of 1,000,000, you can not use so much power on the light source and do it instead on the detector.
And how do you counteract, if you've got gain in an electronic system, surely you're going to introduce noise into the system as well?
Some noise. It depends if you're shot noise limited, and it depends on many factors. So there's obviously ambient conditions, the laser as well. Silicon photomultipliers, for example, are generally low noise, and they're actually capable of photon counting, so you can even count individual photons with them, so noise isn't such an issue.
And I'm right in thinking that some of these technologies already have applications in the medical space as well?
Yes, so silicon photomultipliers in particular, we call it an MPPC. The real main application for that is PET scanners. So how that works is you inject a gamma source into a person, the gamma decays in 2 directions, and you can basically triangulate where it came from and build up an image of a tumour or something. That used to use photomultiplier tubes. It's now moving to MPPCs or CPMs, but basically because it's got a gain of 1,000,000 and it's fast and it's silicon, solid state, rugged, low cost, it makes it ideal for automotive LiDAR as well.
Jack, thank you very much for your time.
Thanks so much, Alex.
I hope you enjoyed watching the video, and don't forget to like and subscribe.